In math today, we will continue learning about data and graphs. Today, we're going to begin with a video that's going to show us a little bit about using data and graphs.
Hey, look at this. It's a picture graph. A picture graph uses pictures and symbols to show data. This one shows how many students in my class like certain colors. Look at the bottom of the graph. It shows the key. The key is just what each picture or symbol represents. Each stick figure represents 2 students. So, how many students list blue as their favorite color? 4? Not so fast. Each stick figure is 2 students. So 8 students like blue. Get it? How many more students list blue as their favorite color than red? 8 students like blue and 4 students like red. We need to subtract. 8 minus 4 equals 4. So, 4 more students consider blue their favorite color than those that chose red. Picture graphs sure can tell a lot of information, and they're a lot of fun to look at, too.
Yesterday, we talked about different types of graphs. This is called a picture graph or a pictograph. I noticed a couple things about it. I noticed that there is a title. I noticed that there are 3 categories, 1, 2, 3. And I noticed that the scale is not 1. Each picture in the graph is equal to 2. We're still waiting on a couple friends to focus. In 3rd grade, we will talk about other graphs that have a scale different than 1. We skip count by 2s in order to understand this graph. This is different than 2nd grade. When I look at how many students like the color green, I can skip count by 2s because each picture equals 2. 2 students, 2 more students, 2 more students. 2, 4, 6 students say they like green. This is what we're going to practice today as we look at using graphs with a scale different than 1. To find our math task today, please click Activities, Assign to Class folder, and Blue Math. Our task today is called Lesson 7-1, Data and Graphs. Please find that and open that, ready to work together. Slides number 1 and 2 we're going to work on together. Today we have some textbook practice where we're going to practice answering how many more or how many less problems. Let's look at our visual learning example from Pearson to help us understand our example from the textbook.
How can you read picture graphs? Think about this question during the lesson. How many hockey teams are in the East Falls League? Let's look at this picture graph to find out. Information you collect is called data. A scaled picture graph, sometimes called a pictograph, uses pictures or symbols to show this information. The scale on the picture graph is the number each picture or symbol represents or stands for. The key on the picture graph explains the scale used in the graph. Look at the graph. What do the two hockey sticks that make an X stand for?
In this example of a picture graph, we have some important information we want to identify. First, I notice there's a title. Number of hockey teams in each league. The data shown in this is all about the hockey teams in leagues. Hockey is a sport. I notice 4 categories: 1, 2, 3, 4. And at the bottom, I notice the scale. The key helps me understand the scale. This one says each little X of hockey sticks is equal to 2 teams. If the graph shows only 1 hockey stick, it's equal to 1 team. So our scale is shown at the bottom. Our scale helps us know, are we counting by ones? Are we counting by 2s, 5s, 10s? What are we counting by? In this example, we're going to count by 2s when we see an X and count by 1s when we see 1 hockey stick. Let's keep going to learn about how to read a picture graph or a pictograph.
They stand for 2 teams. What does a single hockey stick stand for?
We have shared out that 1 hockey stick equals 1 team on the graph.
It stands for 1 team. What will you count by? 2s, 1s?
Select your answer.
In this example, we know that the scale helps us determine how we're going to count. We need to count by 2s when we see an X. We need to count by 1s when we see 1 hockey stick. Our answer is counting by 1s and 2s to read the graph.
You will count by 2s and 1s to find the answers. Use the picture graph key. Look at the data for the East Falls League.
Now we're going to explore reading this example of a picture graph. We're going to try it now. It says select a row in the pictograph to see what it means.
2 plus 2 plus 2 plus 1 equals 7. There are 7 teams in the East Falls League.
So our graph helps us understand the information. Our topic is teams in the league. So in the East Fall Leagues, there are 7 teams. We count 2, 4, 6, and then count by 1, equaling 7 teams in the East Fall League. We're going to use this type of information today as we explore our problems from our textbook. Click on slide number 3, please. On slide number 3, we have another example. This is called a bar graph. A bar graph is another example of a way to represent data. It's different than a picture graph because we draw lines or bars to show the data. We do not draw symbols or pictures, but we draw bars. That's where the name bar comes from. We're going to begin here and use this graph and its scale to answer some questions. Here we go. Look at question number 1. How many goals in all did Alex and Reggie score? So using the graph, we're going to look first at what is this graph talking about? What are our categories? And what is the scale? What are we counting by? We're going to go into a breakout room and I want you to identify with your group 3 things. I want you to identify the title, the categories of data or information, and the scale. With your breakout room, I want you to identify these 3 things using this example. First, we have the title. Hockey goals scored by players. All of the data in this graph is going to be about hockey goals scored by players. Next is categories. I notice the categories are Alex, Cindy, Jack, and Reggie. So we are going to learn about Alex, Cindy, Jack, and Reggie and how many hockey goals they scored. That's what this data is going to be about. Our third thing is the scale. On the left, I see some numbers. It starts at 0, then it jumps to 4, then it jumps to 8. This is a tricky scale because there are some lines between the numbers. Look very closely at the lines. The first mark is 0. But then right above it, boys and girls, we have a mark right here. Then it jumps to 4 right here. So our scale is not actually counting by 4s because it goes 0, line, 4. This is the first mark, which is actually 2. We are going to be counting by 2s with this graph. Sometimes when someone makes a graph, they don't write all of the numbers on the scale to save some space. It gets too crowded. So the first number is 0, then it goes 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That is the scale that we're going to be working with. We are counting by 2s. So let's jump to problem number 1. Problem number 1, let's do together. How many goals in all did Alex and Reggie score? All right, so we need to look at our graph and we need to focus on Alex and Reggie and how many goals they scored. So first, let's go ahead and look at our graph. I notice Alex is green right here, and his bar goes all the way up to right here. If you look carefully, he is above 16 He's below 18. He's below 20, I'm sorry. He is at the 18 mark. Alex scored 18. So I'm going to write Alex. He scored 18 goals in his hockey games. Right now, you are recording with me just like I'm doing. Alex scored 18. You need to write that on your Seesaw page. Now we're going to look at Reggie. Alex scored 18. Let's see if we can determine how many hockey goals Reggie scored. I notice Reggie is shown in pink. Reggie's bar goes all the way up to here and stops. So let's take his line over and see where he lines up. Reggie is at 16 goals. So on the left, I'm going to record Reggie was equal to 16 goals. Alex went up to the 18 line. Reggie's data went up to the 16 goals line. So our question says, how many goals in all did Alex and Reggie score? That's an addition problem. Alex and Reggie all together, that's an addition problem. So we can add together 18 plus 16. Go ahead and find your sum right now. All right, 8 plus 6 is 14. We record the ones, carry a group of 10. Now we have 1, 2, 3 10s. That's the same thing as 30. So all together, Alex and Reggie scored 34 hockey goals. That is our answer to number 1, 34 hockey goals all together. Let's do number 2. Number 2 says, explain how to find how many more goals Alex scored than Cindy. So now we're comparing those words, how many more than. We're making a comparison. We can use the graph. We can look at the graph to see which bar has more, and we can determine how to find that out. So let's look at the graph for Alex and Cindy. Let's identify those categories on the graph. Alex is in green. We already talked about Alex. And Cindy is in purple. So first of all, who scored more goals, Alex or Cindy? Looking for a third grader who can share that out using our graph, using our data. How do we know who scored more goals? Gloria. Alex scored more goals because his bar is longer or taller. Okay, we already learned that Alex scored 18. He was at the 18 mark. So Alex was 18, okay? And then Cindy, let's figure out how many Cindy scored. Her bar goes up to here and goes over to here. Notice that Cindy's bar is in between 12 and 16. So if we're skip counting by twos, 0, 2, 4, 6, 8, 10, 12, 14. Cindy is at 14. If Alex has more, we can subtract Cindy. If Alex has 18, we can take away Cindy's goals to see how many more Alex has. So we can subtract 18 minus 14, get a difference of 4. Or, boys and girls, we can use the graph to determine how many more Alex has compared to Cindy. Look at the graph where Cindy stops, but Alex continues. Look at Cindy's purple bar. She stops at 14 goals, but Alex keeps going because he scored more hockey goals. You could count on and see how many more goals did he score. Starting at 14, you could skip count to 16, 18. Alex scored 4 more goals. He scored this many more goals than Cindy. Today we are going to continue using graphs, using the title, the categories, the scale to help us answer questions. Take a minute to make sure you have number 1 and 2 recorded. Okay, we are ready to go on to slide number 4. Please click on slide number 4 and look at our picture graph. We are going to identify some helpful information with our picture graph before we answer some questions. First of all, let's circle our title. Our title tells us what this data is all about. Our title says hours of light usage at Sports Center. So it's talking about the number of hours the lights are on each week. So that's the data we're talking about. How many hours are the lights on every week? Okay. Next, we have some categories. I count 1, 2, 3, 4 categories. These look like the names of different rooms at the sports center. I see one category is the exercise room, the locker room, the swimming pool room, and the tennis court. So in my mind, I'm thinking about a big sports place, and there's 4 different rooms, and they are keeping track of how many hours the lights are on in this sports building. Okay. Finally, I need to think about my scale. Remember, in 3rd grade, we don't always count by 1. 1 light bulb does not equal 1 hour. Let's go find what our scale does count by. Let's look below at the key to determine how to skip count, how to read the graph. 1 light bulb is equal to 10 hours. If you see half a light bulb, it's equal to half of 10, which is 5. Okay, so I'm going to label my whole light bulbs as 10 hours. That will help me when I'm counting by tens. You can do the same and label your whole light bulbs as 10 hours. Or if you just want to label 1, that might help you remember. Then I'm going to do the same with my half of a light bulb. I'm going to label it as 5. It will help me as I skip count. So where do I have my half light bulbs? I see one here, so that's equal to 5 hours. And I see another one here. This is also equal to 5 hours. Now that will help me when I skip count to find my answers. Take a minute and label your whole light bulbs as 10 and your half light bulbs as 5 hours using the scale. Take a minute to catch up. Remember, you do not have to label all of them, but if that helps you, you should label all of them. Okay, let's think about some of these questions as we go into a breakout room. I want you to start with question number 3. Which area has lights on for the most hours each week? That one's pretty easy peasy. Looking at the data, which room, which area has lights on for the most hours each week? Number 4 says, which area has lights on for exactly 50 hours each week? So you need to look at the graph and see which one has 50 hours of lights on, okay? And then problem number 5, this is a tough one. Ready? In week number 1, how many more hours are lights on in the exercise room than in the swimming pool? Remember that word than is a comparison. How many more hours are lights on in exercise room than the swimming pool? You're going to compare them and see how many more in the exercise room. We're going to go into a breakout room for 2 minutes. I want you to use your graph, use the data to try to answer these 3 questions. For slide number 4, question 3 asked which area has lights on for the most hours. You should have put locker room. We can see clearly that the locker room has the most pictures, the most symbols, because their data is the most. Locker room is the furthest on the graph. Number 4, which area has lights on for exactly 50 hours? If we're counting by tens, I'm going to look at the tennis courts. 10, 20, 30, 40, 50. The tennis courts has 50 hours of lights on. You should have tennis court recorded for question number 4. Question number 5 was the most challenging, but I still saw friends using the data to make a comparison. That was awesome. Looking at our exercise room, compared to the swimming pool, we can see where they line up. I notice they both have 10, 20, 30, 40, 50. They both line up here. But I notice the exercise room has more. So let's do a subtraction problem. How many hours are in the exercise room? 10, 20, 30, 40, 50, 60, 70 plus 5. So 75, I'm going to record that. Subtract, starting with our bigger number, the exercise room, going to take away the swimming pool. The swimming pool has 10, 20, 30, 40, 50 plus 5. That's 55. When you subtract 55 from 75, you get a difference of 20. You could also look at how many more bulbs are on the pictograph. They both line up here, They both have a 5, so we can cross that off. There are 2 extra bulbs, 2 more bulbs on exercise room. 10 plus 10 is 20. That is the same as the difference when we subtracted. 20 more hours is our answer for number 5. Great work in your groups. I'm really impressed with the answers I saw. Let's talk about your task for today. Starting on slide number 6 is your independent task. You do not need to do slide number 5. Slide number 6 is where your work begins today. You need to use the graph to answer each question. Slide number 7 and 8 use the same graph. Slide number 9 and 10 use the same graph. So some of the problems have the same graph, just a new question. You will do slides number 6, 7, 8, 9, and 10 for your independent task today. After your lunch and recess, you will have extra time to get this wrapped up. Don't forget to reflect. How are you feeling about solving how many more or how many less questions using data and graphs? Tell me how you're doing. Are you successful yet or not yet? Still working on those skills. That is all we have time for today. I will be on at 12:45 to answer any questions you have about your math task. It's now your lunch and recess. See you at 12:45 if you have questions.